Well, hello guys, here Mr. G with another video. This time we're going to be solving a question for the grade 10. However, it's applicable for 11s and 12. It is about electrostatic, and this one was question 7 done in 2022 in the Gauteng November examination. But before we answer the question, don't forget to subscribe for the channel and like the video. This question states two identical isolated spheres A and B suspended by a light inextensible string from a ceiling are held a distance apart as shown below, and you have two charges. As you can see, one of them is positive 2 nanocoulomb and the other one is neutral. Sphere A carries a charge of positive 2 nanocoulomb while sphere B is neutral. Alright, now question 7.1, explain what it means but a neutral charge. And what we have to say here? We have to say that the neutral charge is when the number of electrons is equal to the number of protons. There are 2 marks for saying that, guys, and this one you learned in grade 8, so it should not be a problem. It's quite simple if you read carefully. The next question says sphere A is brought near neutral sphere B and the spheres are allowed to touch. So they are going to touch, okay, each other. Immediately after touching, sphere B move away from sphere A. Sphere B now has an excess of 20 electrons, so have extra 20 electrons than protons, né? And this question 7.2 state the principle of conservation of charge in words. So let's write that definition, that principle of conservation of charge here at the bottom for 7.2. all right, so what this principle states? It states that the net charge of an isolated system remains constant during any physical process. There are 2 marks for staying this law. We cannot change it. However, they are very important words that cannot be missed. One of them is isolated system, so the system must be isolated. The other one is the word net. The word net is quite important. If you miss the word net, you may not get the 2 marks. So those are important things to know about this specific principle. Okay, now question 7.3. Briefly explain how the neutral sphere B is attracted to sphere A. Now this one is happening, and this one is important to note here. This is happening before they touch. They are attracted each other before touching, okay? Because if you go back and you read, say that here when sphere B now has an excess of 20 electron, immediately after touching, sphere B move away from sphere A. So after touching, they repel each other. Before they touching, they attract each other. So now why are they attracting each other before they are touching, when they are close to each other? They were far away, now they brought each other close to, and then they attract each other. What is actually happening then? Well, what is going to happen here? This one is question 7.3. What is going to happen here actually is polarization. This charge is a positive charge, and this one is charge A, and charge sphere B, or let's say sphere B, is neutral, which means it doesn't have charge. So what is going to happen is it's going to be polarized by charge A. In other words, the electrons are going to be moving towards this side here because of polarization. So this side of this sphere, this side here, now become negatively charged, because it's negative, né? It's negatively charged. This is called polarization, and therefore as a result they will attract each other. And this is actually what you have to say. So yes, the first thing you have to say is that due to polarization, a negative charge is developed on the side of sphere B near sphere A. And I'm speaking about this side here. This side here become negatively charged, okay? Now, to end, you can say that the spheres move towards each other. Let's write that one. You have to say that the spheres move towards each other as opposite charges attract. So here, guys, you will get 1 mark for explaining this part is due to polarization, which is not very difficult. It's on this side here, and the second mark will be by saying that because they are an opposite or unlike charge, they will attract each other. And that is question 7.3. is a very good question. Let's go to question 7.4. Calculate the magnitude of the charge of sphere B, and they are telling you that there are 20 extra electrons now. So to answer this question, we go to the formulas. which they are here. Here is how the formula we are going to use. That is the number of electrons, that is the elementary charge or charge of an electron, and that is the new charge. So let's solve this question on this side. That one is question 7.4. Alright, so now we're going to write the formula exactly as it is in the formula sheet. Number of electron is equal to charge divided by the charge of electron. The charge of electron is also given to you in the table. So if you substitute here, we have in 20 electrons, this is equal to charge that you are looking for, and the charge of the electron is equal to minus 1,6 times 10 to the minus 19. This one is the charge of one electron, and then you will get that the charge is going to be equal to 3,2 negative 3,2 times 10 to the minus 18 coulombs. That is the charge of B. That is the question, that is what they ask, and it's really simple to do it. So if you do that, you get 1 mark for the formula, which is in actual fact the formula given to you, 1 for the substitution and 1 for the answer. And to finish this question 7.5, they say calculate the charge on each sphere after they have separated. Remember, they came, they touched each other, electrons were transferred from one to another, and they were separated again. So they ask you to calculate the new charge. So let's do this one here. So to get the new charge, Q new is equal to the addition of charge 1 plus charge 2 divided by 2. Alright, so the charge Q new is equal to charge 1. Let's say that one is A. Alright, so it's a positive 2 nanocoulomb. Let's convert it because the second one is in coulomb. So this one here, this charge here will be equal to 2 multiplied by 10 to the minus 9 coulomb. Remember, nanocoulomb you multiply by 10 to the minus 9. Okay, so here when we substitute, we get 2 times 10 to the, let's move it a little bit down, we have enough space. I'm trying to save space, but we have enough space. 2 times 10 to the minus 9 plus all this one, let's open bracket here, plus, and charge 2 is a negative charge, calculated already, 3 minus 3,2 times 10, let's move it again. I now struggling with the space, let's do it there, it's fine there, times 10, 10 to the minus 18 divided by 2, and the rest is just calculation. Q new will be equal to, you will get that each sphere will have a charge of 9,99. In actual fact will be 10 if you round off. This one will be 10. Okay, will be 10 times 10 to the minus 10 coulomb. That is the final answer for this calculation there. And this one, remember, is a question 7.5. Let's write it here, 7.5. And where do you get marks? 1 for the formula, 1 for the substitution, 1 for the answer. This question is done and dusted. It's quite simple, and all of you can get full marks in this question, guys. It's really simple. But thank you for watching. I hope you understand. Next time we're going to solve a question on electric circuit. It's a good question. This one have 11 marks, and that one is the final question of this specific exam. Thank you for watching. Thumb up. Subscribe for the channel if you didn't do yet. I'll see you next time. Mr. G here.